Alright, problem 1H, just like on those other problems, let's start by getting our trig function by itself. So to do that, divide both sides by 3, and we'll get tangent squared theta over 4 equals 1/3. Take square root of both sides to get tangent squared. No. Take square root of both sides to get tangent of theta over 4. It's going to equal plus or minus 1 over root 3. Rationalize that puppy. Plus or minus root 3 over 3. And now here's where you got to do a little bit of thinking. Now again, quick disclaimer, I'm solving these problems how I solve these problems. There's certainly other ways to solve these problems, as we saw in class on Wednesday, but this is how I do it. If it works for you, that's awesome. If you find another way that works for you, that is also equally awesome. But this is what I do. I think about this question. I'm going to ignore that theta over 4 for now. I'm going to ask myself, when is the tangent of some number x equal to plus or minus the square root of 3? And that might be a tricky question to answer because I don't know, it's not as easy to think about tangent as it is to think about sine and cosine, because those are just x and y values on the unit circle. Tangent is our slope, so it's a little trickier. But if you know Mr. Lair's trig table, then it's pretty quick. Or, equally, if you can just do a little abstract thinking, you'll be alright as well. So again, going back to my little unit circle drawing, like all these other problems, think about this. First off, I've got a square root of 3 in my answer, so you should be thinking that I'm going to be dealing with either a pi over 6 or a pi over 3 angle of some sort, because those are values that have root 3 in them. So think about this little triangle we make. We know that this point up here is going to have an x value of cosine, which in this case is root 3 over 2. It's going to have a y value of sine, which is 1/2. Now tangent is slope, rise over run, y over x. So if you think about that right there, we can get 1 over 2 over root 3 over 2, and our 2's are going to cancel, and we're going to get 1 over root 3, which we already showed was the square root of 3 over 3, which is what we're looking for. So now we just need to find all the other values that are going to equal that. So I can continue my line down there because the slope's going to be the same. And then now think about, where is the negative slope of that going to be? Well, that's got to be that right there. And we can get all of our values just like that. We got pi over 6, that's where we started. That's that guy right there. And then over here, 5 pi over 6. Again, this is really stemming from understanding the unit circle and all the symmetry that is inherent in the unit circle. Then we get our next value. Sorry, I'll write that there. 5 pi over 6. Then we get our next value right here, 7 pi over 6. So we're knocking them off. And then our last one, of course, is 11 pi over 6. That guy right there. And we're done. Yay, we're so good. And do you remember 1 second ago where I said, and we're done, yay, we're so good? Yeah, I was jumping the gun, because we're not done, because those are the values of theta, or x, that equal plus or minus the root 3 over 3 for tangent. But again, we started with tangent theta over 4. So I like to think of it like this. All these are essentially x values, all these values right here, that I could throw in to that equation. Tangent of x equals plus or minus root 3 over 3, but we don't want that. We want tangent of theta over 4. So you can think of it like this. We want them to equal the same thing, so we can do a little bit of substitution and think of it as theta over 4 equals those x values, pi over 6, and you can just solve for theta. So to do that, you're going to get theta equals 4 pi over 6, which is 2 pi over 3. Now notice the first step there was to multiply by 4 on both sides. That's going to happen with each of these cases. So I'm going to jump straight to that. And all I'm going to have to do is multiply each of these values that I found by 4 and see which are still in that interval 0 to 2 pi. So we definitely found one solution right there. 5 pi over 6. 5 times 4 is 20. 20 over 6 is not in our interval that we're looking at. So we're screwed. Same with 7 pi over 6. 7 times 4 is 28. 28 over 6, certainly bigger than 2. 11 times 4, 44 over 6, certainly larger than 2. So this is actually going to be the only solution in the interval that we're looking at. And again, all these problems, you can actually graph them and check. Not on the test, because it's going to be no calculator, but when you're practicing these, it's a good idea to actually graph them. That's what I did when I was doing them, just to confirm what you're doing algebraically. It's nice to see it verified in a different form. So whatever works for you, but I think that's pretty cool, and we're done.